So this video is going to show how to do linear and exponential regression in Excel or in Google Docs, and I'm going to show it in Google Docs since that's something that you probably have access to. So I'm going to head over to Google Docs or docs.google.com or drive.google.com, and I'm going to hit create and say I want to create a new spreadsheet. And that's going to create this spreadsheet for us that has these cells that we can put stuff in. So the problem we're going to work on is this one. We want to find linear regression here, try to fit a line to this data. So I have these years, these t-values, which are years past 1989, and these costs. And I'm going to go record these into my table here. So I'm going to go ahead and create one column for t, another column for cost, and I find it easier to do things vertically rather than horizontally here. So I'm going to go ahead and record the values from the table that we had for the costs, and then I'm going to record the sorry, those were the years, and now I'm going to record the costs. 12,990 and 15,030. Okay, so now that we've got those done, one thing we might want to do is visualize this to see if it even makes sense to be talking about linear regression. And so for that, we can highlight the data, come up to Insert, and say we want to insert a chart. And the type we're going to use is a scatter plot. That type there, scatter chart. And we're going to say, okay, go ahead and insert that. And there we go. So that's what our data is going to look like. Along the horizontal, we've got our t's, and along the vertical there, we've got our costs. And we could look at this and say, it kind of looks linear, fairly linear. So let's go ahead and see if we can fit a line to the data. So I'm going to go ahead and delete that just to get out of the way. So this is not quite as easy as it is on the TIs, but it's not too bad. So the way we can do it is we can come down here and we're going to hit equals, because we have to start with an equals when we're going to do a formula, and we're going to type LINEST. That's, like it says, best fit linear trend used via least squares. And I'm going to start a parenthesis, a left parenthesis, and now it's going to tell me what I need to do. It's going to say it needs the y values, then a comma, then the x values. So I'm going to come up here and just click and drag to highlight the y values, and then I'm going to type a comma, and then I'm going to go, now it's telling me I need the x's, so I'm going to go click and drag. Now it's saying y's and x's. Of course we know that means outputs and inputs. So outputs first, then inputs. And that's all I need. I'm just going to go ahead and hit enter, and it's going to calculate two things there. The first one is going to be the slope. The second one is the intercept. In other words, it's telling me that the linear equation would look like y equals 408.0239 x plus, or t, plus 1008389. Roughly, and that should really be C, not Y. So there we go. There is approximately my linear regression line using Google Docs. So now we're going to look at how to do exponential regression. So same idea. Let's imagine that we had some data, and just for simplicity, I'm going to go ahead and use the same data, even though I doubt that it's exponential. It's very similar, just instead of LINEST, we're going to use logest. So LOGEST, and that says fit an exponential growth curve. So first thing we need is the y values. Again, the output values. So we're going to, oops, I got in the wrong place there. So, oops, got another thing. Okay, so there, go drag the y values, comma, drag the x values. And there we go. There is my equation. So this first one is going to be the growth factor, and this one is going to be the intercept again. So somewhat similar to slope and intercept, it's growth factor and intercept. And so this would have the equation 1020095 times 1.03313 roughly to the power of t. So that's the exponential equation that this function is suggesting.